evening, everyone. Good evening, UNIJOS. Welcome to the very first edition of DigGeoNaija University Affiliate Program, DUAP. And guess what? Today we are making history today as our pioneer university audience. And this is just not a regular workshop. It's a hands-on geospatial workshop where you will learn how to use digital tools and to understand the world around us. I'm Lawal Timtope, and I'm not just here alone. I came with my colleagues who will be our tutors for today. So kindly, I hope we've all installed our QGIS. So let's get into it. So what exactly are we doing today? This workshop is all about learning by doing. We will take you through the basics of GIS and show you how to work with DEM, how to process and visualize maps. And we'll be using QGIS, which is a free open source mapping software, which is used by professionals around the world. And by the end of this session, you will know and be able to create beautiful maps and even surprise your lecturers with your new digital skills. And these sessions will last for 2 hours. We'll keep it fun, practical, and if you have any questions along the way, just drop it in the chat box. Thank you. So I would like to tell us a bit about who we are and what we do. We are DigGeoNaija, and DigGeoNaija means Digital Geoheritage Innovation in Nigeria. We are a tech-driven initiative elevating Nigerian tourism sector through immersive experiences and sustainable practices. Our mission is to enhance accessibility and conservation of Nigerian geosites while promoting sustainable tourism. And our vision is very simple, which is to use cutting-edge immersive technologies and innovations to bring Nigeria's geoheritage to the world while also ensuring preservation for future generations. So what kind of things do we actually make? We create virtual tours of geosites and also 3D geosite models for academic and professional use, thematic and XR cards, digital DM and GIS maps, and site artworks and merchandise, documentary series, which you will find on our YouTube channel, geoheritage storybooks and educational tools, training and consultancy services for you and also for professional use also. So I would like to call on Ridwan, one of our tutors, to guide us through the thematic mapping and the Ridwan, good evening. Over to you.
Thank you, Temita. Good evening, everyone. Good evening, UNIJOS. Thank you for having us. Thank you for having DigGeoNaija. So, like you said, this is the first beneficiary of the DUAP Ambassador University Affiliate Program. So, I'll be taking us through the introduction to QGIS and also thematic mapping as a whole. What is thematic mapping? What do we use it for? How do we use it? And what are the reasons why we carry out geospatial analysis? Please kindly confirm if you can see my screen before I proceed. Just use your thumbs up. Okay, thank you. So, oh, is there someone there? Oh, we'll be having a question and answer session in 30 minutes time. But if you're encountering any challenges, you can drop your question in the message chat box. So, what is thematic mapping, and what is the what are the sources of DEM, and what are the applications of thematic mapping in terrain analysis? So I'll be putting us through all this, and I'll be making us understand what digital elevation models are, what are the sources of digital elevation models, and how, what is QGIS itself? How do we prepare our data in QGIS? I'll be taking us through this part before I hand over to the next tutor. So my name is Ridwan Hosseini, one of the members of DigGeoNaija. And like I said, I'll be putting us through thematic maps. So what are thematic maps? Thematic map is a type of map that is usually designed specifically to a particular theme. It is used to emphasize a particular purpose or subject area. So for instance, you are trying to investigate the variation in precipitation patterns in JOS, and you don't have to go to the field, you don't have to be there in person. All you need is data. Data is information. So your map is as good as your data. And unlike the general reference map that usually emphasize the variety of geographic features, thematic map only focus on the data related to your analysis. So for instance, there is okay. Please drop your question in the chat box. Let the other members attend to it, please. So unlike thematic, like general reference maps that show a variety of geographic features, thematic maps only focus on the specific data that are related to the analysis, such as population density, and like I said, climate patterns. When you want to investigate variation in precipitation patterns, rainfall, or temperature, you can decide to create thematic maps for this purpose. You can also investigate land use patterns, land use variation in years where you don't even have an idea what is happening. All you need is your satellite images, and you can create your thematic maps and see the variations in person. So these maps are actually used to visualize spatial distributions of a specific phenomena, like I said. Okay. So what are DEMs? So DEM is a type of data that we use in geospatial analysis, and it is the short form of digital elevation model, which are raster-based GIS data that has elevation values, elevation information embedded into it, and we use this for visualizing elevation data across a particular location. And we have two types of DEM data. We have the DTM and we have the DSM. What is the difference between these two? We have both of them displayed on our screen. And the first one on our screen is the DSM, which is the digital surface model. This particular one, I mean, is on my screen. So this is the so this is the this right here is the DSM, which is the first type of digital elevation model we have. It has both natural and anthropogenic features on the digital elevation model. That means on one data, you can visualize the natural features of the Earth, and you can also visualize the artificial features, which include building, roads, and different structures on the natural feature of the Earth, which means that this digital elevation model can show us the elevation of the Earth in addition to the elevation of the structures that are on the Earth. So the second one is the DTM, which is the digital terrain models. It consists of only the natural features of the Earth, no anthropogenic features, and this is it over here. We can look at both data. We can see that there are some patches or something here. This is Stonehenge in England, and these are the anthropogenic features on our data, as you can see, while the other one is a clean version of the data, which includes only the natural features of the Earth, no addition or no anthropogenic features embedded in this data. So what are the sources of our data? We have the SRTM, which is the short form of the short radar topographic mission. It has a resolution of about 30 meters to 90 meters, and we use this mostly in our analysis. We can get this, it is accessible through NASA and USGS. And another type of sources of DEM data is the ASTAR, which is the short form of Advanced Spaceborne Thermal Emission and Reflection Radiometer. It also has a resolution of about 30 meters, and this is particularly useful to geosciences also. We use this in geological mapping for people that are into prospecting of mineral resources, You can use this depending on your skills. And we also have LiDAR, which is a short form of light detection and ranging. This technology is scarce in our region here, but it is mostly used all over the world, and it has a very high resolution of about centimeters to about 1 meter. And this is a point cloud version of data which can be used to generate high resolution DEMs, and it provides more accuracy compared to the first two sources of DEMs. So, what are the applications of thematic maps? We use these maps, which are um, thematic maps. We use them in geological and geophysical studies, like I mentioned. We can use them to map rock formations. We can use them to map fault lines and mineral resources. We can use them to identify areas that are prone to earthquakes and volcanic eruption, like this geological map we have here. We can see some volcanics on our geological map, and this is the geological map of an area. And we can also use thematic maps in land use and environmental monitoring. Like I said, you can access the land surface variation of a particular area. What structures were here in year 1970, and what structures do we have here in 2025? What's happened to this land? Is there deforestation? Is there afforestation? We want to monitor the environment. We can make use of thematic maps, and we can also track desertification, urban expansion through the land use thematic maps. We can track biodiversity and also visualize protected areas for conservation efforts. We also use thematic maps in hydrology and water resource management. We can map river basins. We can identify flood-prone areas, and also monitor groundwater levels and uh, visualize water pollution. So another one of the uses is also the climate and weather analysis. Like I said, we can visualize the precipitation variation of an environment. We can display the temperature variation, rainfall distribution, and also the weather events that have occurred in a particular location. We can understand the climate change of a region. So let's go through the interface of QGIS. What does it look like? What does this software look like? How do we use it? So this is QGIS. How many of you have this software installed? Please just show me your thumbs if you have it installed. Okay, that's good. Okay. So do you have it on? If you have it on, your software should give you this interface after selecting any project. Note that you have to open your QGIS, select a new project, and you have this interface on your screen. So if you have this interface like me, ensure you have your CRS set to 4326. How do we do that? We can click on this. Whatever CRS you have there, just type in 4326 into this part of the screen and select this once it pops up. This is a global CRS for the Earth, and you can apply and select OK. If you've done that, just show me your thumbs. Anyone else? Okay, thank you. So this is the interface of QGIS, and over here we have the layers panel where we display our layers which we use for analysis. We have all our layers available, the ones we are using currently and the ones we don't want. This is where we all get them in QGIS, where we turn them on and turn them off. And we also have the browsers panel where we can import some data we want directly from our storage system. And we also have the locator bar where you type in whatever you want to search for in QGIS and it pops up. We also have the status bar where we have the coordinate referencing system and the coordinate referencing system that I just said now. We also have the menu bar where we select different options that can be used in QGIS. We have the toolbar, so we have the toolbar up here, and this is the processing toolbar. To turn this up on your screen, you can click on these settings and it will turn up on your screen. So how do we import a data into QGIS? What are the data we use in QGIS? We have two type of geospatial data. We have the vector data and we have the raster data. So I will import a vector data for us, and we can see what we can do with vector data. Some um, features that we can use in QGIS to perform a quick analysis on vector data, and I will show us what the other type of data look like before Ms. Victoria take over and put us through what particularly we use it for. So to add your layer to QGIS, you can come to our menu bar up here and we'll select the layer. Once you select layer, you have this drop down and you can click on add layer. So once you click on add layer, there is an extension just in front of our layer where you can select the type of layer you want. So like I mentioned, we have different type of GIS data, but the two main data we make use of are the vector and the raster data. So I'll be importing a vector data for us, and we can see what a vector data looks like. So to import a vector data, you can select the add vector layer and you will have this on your screen. If you are currently on the same page as me, just show me your thumbs, let me know you're following. And to the people raising up their hand, any issue, are you having any difficulty? Have you been attending to? No one is dropping any question. So if you have this on your screen, dots here to browse to your storage and select the vector data. That is if you have it in your storage system. So I have this in my storage system, so I'll click on it and browse to my folder. I can click on only, I will click on only the files that are having the .shp extension, and you click on having .shp extension, and you can click on add. So for some of us, we may not have this data in our storage, as maybe we are new to it, but you can access this in QGIS. How do we do this? You can come to the menu toolbar and select plugins. Once you select plugin, you can click on manage and install plugins. Once you click on this, we a plugin that can help us fetch this vector data for Nigeria. So to do this, let's wait for the yes. So you have this on your screen after selecting plugins, and in the search bar, just type HCMGIS. HCMGIS, like you can see on my screen. So once you search for it, you will have this option and you can select it. I have it installed already, so I don't need to install it again. But let's give us a minute to install. For some of us that don't have it installed, you can click on install and it will be installed. So if you are currently on this, just show your thumb so we can follow together. Any of us are on the same page? Done this already, you will have your so you can close this after installing, and this plugin will be added to your menu toolbar. So once it is added to your menu toolbar, you can download a vector data of your choice. So I'll be downloading for Nigeria by clicking on the HCMGIS toolbar, and I'll select download open data. So once I select download open data, there is an extension in front of this option where I can select other type of data I want. So I'm downloading the global administrative areas by country. It's the second option on my extension. So I'll click on this. And I can select my country, which is Nigeria. And you can see your browser your choice and you can save it. Once you save it, you can apply and it will download the vector data of Nigeria to your QGIS. So if you can just try this and let's see your screen. Anyone, if you've done this, just show us your screen. Let's see what you've done. Once you do this, you will have your vector data added to your interface. Anyone? Okay, so and this is the administrative level 1 vector data of Nigeria, where we have all the 36 states. And to perform a vector analysis on this, let's um, identify which state and what data do we have here. So to do this, I will click on the layer and I'll click on this ABC icon up here. Once I click on this, I will have the option to edit my layer, and I can click on this drop down here where I have no labels, and I'll select single labels. So once I select single labels, I'll I can, as you can see, we have the names already displayed, and I can close this. So to do this again, another way to do this, you can click on the data and right click on the data. Once you right click on the data, you have properties down here. So you can click on properties and you have all the information of the vector layer displayed. So you can select your labels and do the same thing that I did. You can select single labels and apply. So once you do this, you have your labels, and as you can see, we have Plateau here, we have Nasarawa, the Federal Capital Territory. So I'm extracting Plateau State and a closer neighboring state of Plateau for my analysis. So that will be Nasarawa. So to do this, I'll click on my data, and I can click on this file here to pick any area of my choice, or I can open my attribute table by right-clicking and selecting Open Attribute Table. So let me scroll down to where we have Plateau and Nasarawa. So this is Plateau here. I'll click on the ID number, which is the 32, number 32. Once I click on this, I'll close my attribute table, and we can see Plateau State is highlighted already. So I want to export this, and I want to isolate this from the larger data. I will do this by right-clicking and coming down to exports. Then I'll save selected feature as Plateau. So you can click on OK, and you can see we have the data is separated from the main data. So I'm exporting another state, which as I mentioned earlier, the neighboring state, which is Nasarawa. So to do this, I can click on this and select this tool up here. Once I select it, I can click on Nasarawa and then right-click and export, just like we did for Plateau. So I'll save selected feature as Nasarawa, and I can select OK. So once we do this, we have Plateau State and Nasarawa State isolated from our main data. So we can display the labels using this icon by selecting single labels, and we close it. So Plateau, we do the same for Nasarawa by clicking on the layer. I will select this icon, ABC layer labeling. So we can click on single labels. We close it also. So let me pick up my panel tool and let's start our vector analysis. So what we did now, we just extracted our area of interest from a larger data set. So let's merge these two layers together, Nasarawa and Plateau. Let's turn them to one whole data, one uniform layer. So to do this, we can select vector from our menu toolbar, and we can come down to data management tools, and we have this extension in front of our option. So I can select merge vector layers. So I'm merging the vector layers, and you have this on your screen, this pop up, and you have a section asking you to input your layers. In this section, you can click on the three dots in front and select the areas you wish to merge, which is Nasarawa and Plateau. So once I select both of them, I'm clicking on OK. You can tell the software your destination CRS, which mine will be the project CRS I'm using. So If you wish, you can save to your file, or you can create a temporary layer. The software automatically creates temporary layer, which although will not be saved in case you want to come back to your analysis. It is a temporary layer, but for you, you can save to your file and you browse to your storage and save. So I won't be saving, but I can click on run. So once I click on run, I have my merge layer here, which is the second layer. And as you can see, we have both Plateau State and Nasarawa State as a uniform layer. I can display their labels just like we've been doing by clicking on this icon up here, and I will select single labels. Then I can close. So this is a merged vector layer for both Plateau State and Nasarawa State. So I want to break this down back. I want to make them single. I want to separate Plateau from Nasarawa State. What do I do? How do I achieve this? I can come again to vector and select geoprocessing tools. Then I select clip. Okay. 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 So I'll select the input layer as my merge layer. Then I want to overlay it. What am I using to overlay it? Which layer am I trying to separate from which layer? So I'm trying to separate Plateau State from the merge vector layer. So I'll click on Plateau. Like I did earlier, I'm not saving, but you can save by clicking on these three dots here and save to your file. Ensure you save your work so you don't lose your training results. So I'll click on run after doing this. I'll select close. So we can see we just clipped Plateau State again from our merge vector dataset. So I want to display the label by clicking on the clip dataset. I'll select this ABC icon again, and I can select single labels from my drop down. Then it has been applied. I can close, and this is Plateau State. So the other type of geospatial data we make use of, which is the raster data, will be introduced to us by Miss Victoria. But let's visualize what it is and let's see what it is. So to do this, I can click on layer and add layer. Then just like I mentioned earlier, you select the type of layer you want to bring into QGIS. So I'm bringing raster data this time around. So I'll click on add raster layer. So once I click on this, I will browse to the location of the raster data I want. Then I can click on browse. So I have my layer stored in one of this folder, which I'm selecting, and I'll select add. Then I can close. So this is the other type of data for the whole of Nigeria, which is totally different from the one we just used. So I'll be handing over to Ms. Victoria to take over from here, making use of this new data I just added to my interface. Thank you.
Good evening, everyone, and a warm welcome once again. My name is Oludipe Victoria, and I am truly delighted to be here today. It's a pleasure to share this session with such an amazing audience. So in today's live demonstration, I'll be walking you through how to create a thematic map using digital elevation model, which is known as DEM. So we are also going to create a hill shade map, a slope map, an aspect map, and a terrain map. So we will learn how to put all this together, and we will design a professional map layout. So by the end of this session, you have a solid understanding of these essential geospatial techniques. So what is a DEM? What is a digital elevation model? This is a 3D representation of the terrain surface. So specifically, it shows the elevation or height of the land at different points. So they are basically raster files where each cell, which is known as pixel, has an elevation value. And they are useful in GIS and remote sensing to analyze the terrain. Most of the common application of this is in slope and aspect analysis, drainage modeling, flood risk mapping, 3D terrain visualization, and so on and so forth. So the first thing we're going to do today is how to add DM from QGIS. So this is what my interface looks like, as Mr. Ridwan has put us through how to extract our study area. This is the boundary of Plateau State. So first off, if we want to acquire our DEM from QGIS, you come to raster, then go to open topography DEM downloader. Although you may not have this as a first time QGIS user. So what you do is go to your plugins, then manage and install plugins. So here you can have a lot of plugins that you can use for different analysis in QGIS. So once this comes up, you just search for open topography. So you click on this and then you can install it here. Since I already have it installed here, there's no need of reinstalling. So I'll just close this. So once you install that, you can go to raster, then open topography DEM and select the extension. So there are different data you can get from this open topography. We are going to get the SRTM 30, which is the shuttle radar topography mission 30. This is of a higher resolution than the SRTM 90. So when we click on that, we're going to define the extent to download, which is our study area. So we'll come to this drop down button here and go to calculate layer. Then we select Plateau State, since that's the region we're working on. Then there will be, this part is going to be here where you have to enter your API key. This API key, you have to get it from the Open Topography website. I already got mine, so you input it here when you get yours, and you can click run. Because of the amount of time it might take to download, I already downloaded mine for Plateau State. So if you already have yours in your system, you can just import it into QGIS. So you go to layer, then add layer, add raster layer. It's a raster file. So you come to these 3 horizontal dots here, and you browse to where you have it. This is mine, and then I'll add it. Once you download your SRTM 30 DEM data, this is how it's going to look like. It's going to download areas that are outside Plateau States also. So we have to clip it in order to have that of Plateau States, our region of interest only. So to do that, we go to raster, then extraction, then clip raster by max layer. So our input layer will be the DEM we downloaded, and the max layer will be our region of study, which is Plateau State. So once you do this, you can just hit run, and it's going to take a moment to analyze. So the analysis is done, and if I uncheck the main SRTM I downloaded, I can see the clipped layer for our region of interest only. I can right click on this to remove the one I don't need anymore. Now this looks like a blank data. We cannot really visualize something here. So in order to interpret what this is, we can style it. So just right click on this and go to properties. And then we change the render type to single band pseudo color. So we can add color and style our data. The interpolation can be changed, but I'll leave mine as linear. The color ramp also, you can choose any color ramp of your choice, and you can also create new color ramp also. If you come to this all color ramps, you see all the color ramps you can choose. But I'm going to choose turbo, and the mode will be continuous, and I click OK. Now we see that the DEM data has changed. So this is our 3D representation of Plateau State. And from the legend here, we can see that the value ranges from 98 meters to 1,744 meters above sea level. And from the color ramp here, we can see that the areas that are blue, it ranges from blue to red. The areas that are blue are the areas of low elevation, while these areas are of higher elevation. So we can also visualize, which part in Plateau State has this elevation. So we'll go to global administrative level 2, and we'll select all the local government areas in Plateau State. So we can do that by right-clicking on this and going to open attribute table. Every vector layer has an attribute table where you can visualize what it contains, the attributes of that particular data. So browse to Plateau State. So this is Plateau State and the different local governments from Bakinladi down to Wase local government. So I'm going to select all of that, and because I want to have this alone. So after selecting all of that, I can cancel this, say it is highlighted. So I'll right click on this and export. So I'll save selected feature as, let me say, LGA, that's local government area, and I'll click enter. You can see that we have only that present in our layer now. So I can style this so that I can see my DEM data beneath. So I'll do that by right clicking on this, go to properties. Then I want just the outline of the states. If you don't, it's only blue, red, and green that is here. If you want to change the color, you can, there are other colors you can change it in. So just come over here and then you can change it. I'll choose black and then I'll select OK. So now we can visualize this, but this is incomplete if we don't have our labels. So I can right click, go to properties, then labels. From no labels, I'll change it to single labels and change this to ABC name 1, the value. So I'll select OK. So now the values, the local government areas are already added. You can see the local government area where you live in. If you are in UNIJOS, you should be in just local government, there's just East and all of that right there. So the next map we're going to be creating is a hue shade map. This map is a shaded relief that visually represents the terrain surface by stimulating the effect of light and shadow on a landscape. This is also generated from our DEM map that we have here, and it makes elevation data looks like 3D. So one thing about hue shade maps is that it helps you to visualize different landforms that are present in your region of interest, like the valleys in an area, hills, plateaus, and all of that. So let's go to how to create the hue shade map. I'll uncheck this. So you go to raster, then analysis, then go to hue shade. So our input layer will be our DEM data, and we can change our vertical exaggeration to 0.004. And the azimuth of light should be 315 and the altitude of light 45. So we can hit run. So once that is done, this is what our hue shade map looks like. So we can style it to look better. Can right click, go to properties. The minimum value should be left at 1, and we can change the maximum value to 181. The brightness, we can put it at 50, change the gamma to 2. Then the grayscale should be by lightness. We can change the contrast to 35 also. And our sampling should be at bilinear. So we click OK. So now this is what our hue shade map looks like. So another thing we can create is contour lines. We can create contour lines using digital elevation models also. And this is used to represent elevation in a simplified format. It is used to visualize terrain relief. It gives elevation information also. And it is also used for slope and gradient analysis. So to create contour lines, you can go to raster, then extraction, then contour. So your input layer will be your DEM. You can see there are a lot of purposes for this DEM map, and you can set your interval to be maybe 50 or 100, depends on what you like. You can leave the rest as default and click run. Because of the amount of time this may take to load, I already did that. So we'll go to import this into QGIS. You can go to layer, then add vector layer. So I'll browse to where I stored it in my system and go to contours. It is a vector file, so I'm going to import the .shp version and click add. So now this is what our contour looks like. If I right click on this and open attribute table, we can see the different elevation values for each of the contour line. You can see lines of equal elevation, 840 meters down. We have areas of high elevation too that are there. And you can right click on this and click show labels to add the labels to our contour lines. These contour lines are also useful for hydrological analysis because contours help to identify flow direction in an area, like where water how water flows in plateau states, for example. And it is also used to analyze potential flood risk zones. So another map we can create using this DEM is a slope map. A slope map basically shows how steep a terrain is at different locations. So it is also derived from these digital elevation models, and it expresses the rate of elevation change, and it is expressed in degrees or percent. So let's go to how we can create a slope map. You do that by going to raster, then analysis, then we can select slope. Our input layer will also be the DEM, and we can leave the rest as default, or you can tick compute edges and select run. So this may take a while to load. Once it's done, just click close. This is what the slope map looks like. So we can style this to be visually appealing. You just right click on it, go to properties. Then our render type, we change it to single band pseudo color. The interpolation, we can change it to discrete. Then our color ramp also, we can leave it as toggle, or you could change yours. The mode, we're going to change it to quartile, and we can leave the classes as 5 classes. Then select OK. So this is what our slope map looks like. And this is our legend over here showing us the different slope variation. So let's go to how we can create an aspect map also. This aspect map shows the degree of inclination of a terrain. So we can do that by going to raster, analysis, then aspect. Our input layer will also be our DEM data that we downloaded, and you can just click run. You can see how easy it is to just perform any analysis using just your DEM data that you have. So this is our aspect map, and then you right click on this, go to properties to style this, change the render type to single band pseudo color, and you can select OK. So this is what our aspect map looks like. So it tells you whether a slope is facing maybe north or south. So this slope and aspect map, they are very useful for environmental studies. They can help you to understand erosion patterns and land stability. It is also crucial in land use planning and agriculture. You can also use it for flood and hazard mapping also. It is useful in different courses, not only geology. It's also useful in construction and engineering also. So now let's create a terrain map of Plateau State using our DEM and our hillshade map. So I'm going to make sure that only the DEM and the hillshade map is ticked on. So in order to visualize the hillshade map, because once this is above the DEM, let me rename this. So to rename a layer, you can right click on this and rename layer. So I'll just name it SRTM 30 meters. So to visualize the hillshade map that is below our SRTM in our layer panel here, you can just right click on this and go to properties. So in our blending mode here, instead of it being normal, we're going to change it to multiply. So once you select OK, you can see now that our hillshade is shown beneath our DEM data or our SRTM 30 data. Now, this is a beautiful terrain map of Plateau State, and we can overlay it with our local government area. I'll just bring this on top. I can also, since the names of the local governments are not really showing, I can just style that, right click on the LGA layer, go to properties, and I can change the color from bringing black to, let's say, red. Let's choose red and click OK. So we can see that it's showing now. So now your making a map is not enough. You need to also create a map layout, which is also known as map composition. This is the final polished presentation of a map that combines all its visuals and elements in a clear and meaningful way. So this is what you produce when you want to share your map with others, whether as a report or as a presentation, or maybe you want to print your map and show it to people. So you have to add some essential elements, and just like maybe a title, legend, not arrow that I'm going to show you. And let's get right into it. So in order to do that, you go to projects, then new print layout. So once you do that, we can name it Plateau State. And click OK. So it's going to show you another layout. This is your new print layout where you prepare your map to be exported. So this is your page where you prepare your map. You can decide to change the page properties. This is landscape. You can decide to change it to portrait to accommodate a bigger map, but I'm going to leave mine as landscape. So in order to add our map in which we've prepared here to this our print layout, what we'll do is we go to add item, then add map. So we can just, the arrow is going to change, and then we'll just draw our map over the Canva. Now this is what our map looks like here. In order to make it bigger, we can change the cursor to move item content. So we just zoom in a bit. So this is better. Let me zoom out. Okay. So now we have to grid our map. But one thing we have to do is we have to ensure our coordinates reference system, just like Mr. Ridwan taught us, is the same with our projects that we have here. If not, you have issues creating your grid. So I'm going to use the project CRS, and then I'm going to grid the map. So before that, I'll add frame, and then go to grids. I'll click this plus sign here, select this and modify grid. So our X and Y, I can use 1 meters. I can see our grids have been added. And then I'm going to draw coordinates on the map to show location. Then the format, you can leave it as decimal, and if you want to change it, you can use DMS, anyone, but leave it as decimal. Then we'll make sure that each and every part of the coordinates in the left, right, top, and bottom is inside the frame. Bottom part inside the frame. So we'll go back and then we'll lock all the layers, because if you don't, it's going to, if you decide to add another map, it might change this particular one you have here. So you have to ensure you lock it up here and then you lock it down here also. Once this is added, you can add a scale bar, a scale to our map. So we just come to the left hand side and click add scale bar. So you draw your scale on your map and also lock that. So once that is done, we can add our north arrow. These are the essential elements you need on your map. So if you don't like the arrow you have here, you can decide to change it. I can change mine to the one that has N on top, and then I can change the color too from white to black, and then I'll lock that also in order for this not to move. Now I want to add an inset map that shows Nigeria and the location of Plateau states in Nigeria. So what I'll do is I'll go back to my original map Canva here. This is where you prepare your map. I would uncheck each of these and make sure that it's only our region of interest, Plateau states. Let me add label to this. And then our Nigerian map. I'll right click and zoom to layer. So this is Nigeria and this emphasizes Plateau states here. So I'll just add the map over on our map Canva by going to add item and add map. So I can just draw the inset map here. So this is it. You can decide to make it bolder. And then I'll grid the map also. I'll first add frame and then grid the map. So the X and Y, I'm going to use a larger value since it's a smaller map. I can use 8 meters. Then I'm going to draw the coordinates also. And make sure that all the coordinates are within the frame. For the top also inside frame and the bottom inside frame. So once that is done, I'm going to lock the layers also. So this is our inset map. I'm also going to add a scale to it. So this is what our scale looks like. It's very tiny. So in order to modify this, make it bigger, we'll scroll down on our item properties here and select fit segment width, and we can change the length, the breadth, and the height. You can use 10, 30, and 1.5 millimeter. And then I'll adjust this to be inside here. So I'll lock this also. So the final thing we'll be adding to this map is, okay, not the final thing. We're also going to add a legend. So you just click add legend here and draw this anywhere you like on your map. So I'll just fit it into this place. And I'll title it as legend. So you scroll down and uncheck this auto updates here. Because if you have this checked, it's going to bring in every of your layer that you have here, and you may have some that you don't need to be added in your reports or your map that you want to export. So I'm going to uncheck this since I don't need slope. I don't need the contour also. So I'll just remove those ones that I don't need. I'm going to remove contour. You just select it and click on this minus sign here. And I don't need this also. So these are the only things I need on my map. And I'm going to arrange it the way I would like it to be. Since the local government area is on top of the SRTM, then the hill shade, I can expand this. So this is it. Then I can change the name of this one too. So let me just use NGA to show Nigeria. Insert map. Then I'll add a frame to our legend and lock it up here also. So this is our legend. Then let's add a title to our map. I'll go to add item, then add label. So I'll just draw this over here to add the title. So this is where you type it. You can remove this and let's say terrain map of Plateau State. So since the font size is very, very small, we can change that. You just scroll down and this font here, we can increase it to, let's say, 70,000. It's too big. We can reduce it. Okay, this is okay. And then we'll lock it also. Now we want to export this map as an image that you can add to a report or a journal. So what you do is you just come over here and tick export as image. You can also export it as a PDF or an SVG file. So I'll come over here and select export as image. So I'm going to browse to a folder that I want it to be in, and I'll name it terrain map and click enter. So the export resolution, I'm going to use 750 dpi because you need a very high resolution so your map can be very clear, and then you save it. So this may take a while to save, and once you save your map, you can view it in your folder. So this map layout that we're doing, it ensures professionalism. So it gives your work credibility also. Is there any issue? Okay. All your questions will be attended to shortly. So our map has been saved, and let's look at our map, please. Our final map. So this is what our final map looks like. You can add this to a report, or if you want to give a presentation. This, isn't it beautiful? So you can encounter some common errors while doing your map, and they include projection mismatch. You always have to check if your coordinate reference system is okay, like the coordinate of the particular place you are working on. And also when you are adding your layers, you have to make sure you know what type of data you are importing it is, whether it's a vector data or a raster data. Another thing is you have to make sure you have enough storage on your system. you have to have at least 20 gigabytes of space for on your system for QGIS to function properly. And also, you always need to have the updated version of QGIS so that it can support certain plugins that you might need. So I'm going to hand over to Mr. Monday to lead us with the question and answer session. Thank you.
Wow. Thank you so much, presenters, for the wonderful presentation. We'll go straight into the question and answers session. Okay. Okay. Amos Benjamin is saying, I'm finding it hard following every steps because of the speed the presenters are using. Please, can we get the recordings at the end of the session? Okay, I think Ayomipo responded. Okay, Amakundi, I think it's the same problem also. He said, please, can we have a video record of this at the end of the class? Because network issue has been a big issue over here. So I think the problem we have, or the questions most of us have, is asking if the video recordings are going to be available at the end of the training session. Deborah is also saying, hello, please, could we get the recording and data sets you are working with, or you could show us how to get them alongside the other things we downloaded during the lecture process. It will greatly facilitate our learning. Thank you very much. I think these are the questions that are available for now. I don't know if what else will come in, but this is what we have for now. Ayomi, but you can speak, please.
Okay, good evening, everyone, once again. My name is Ayomipo Bankole, and thank you, Monday, for the organization so far. So, in terms of the recording, we are not guaranteeing you that, because we are taking into consideration our property, and because it's confidential, so we are not guaranteeing you. So that was the reason why I said, if you have questions, it's better for us to treat it. But we are also looking for method that we can make you access the recordings. So, but either ways, our decision on that we get through to the ambassador, which is Monday Tonga. And once we finalize on that, then we'll disseminate the process of accessing the recording, if that will be if you'll be allowed to get access to it. But for now, if you have any questions as regards the presentation so far, you can just put that across while we answer them. We still have time for us to answer the questions.
Okay, thank you, sir, for that. So okay, Mr. Bunyamin Luisa, please, you can speak, sir.
Okay, thank you so much, Monday. Good evening, everyone, and thanks to every one of you here for making it here, and really thank you to DigGeoNaija, Ayomipo. I know our our back end conversations and everything towards the planning. Monday, everyone, well done, Ridwan, well done, Vicky, for the presentations. Hi, Gania. Well done, everyone. I want to say it's been a very nice outing, and really kudos to everyone that have presented, and for everyone that made it here to even follow up. I know for a lot of the students here, or a lot of us here, this will be the first time working or being walked through the QGIS. I know a couple of persons that missed the last general training, which I understood was for Cameroon. And I think after some talks, we were able to get it extended to everyone. I'm sorry to say, but my dismay is the fact that the numbers weren't too encouraging, and I understand the clamor for the videos. I wished we were able to have installed these softwares, or we would have been able to follow up with everything that was being done. But I believe, at least, no matter how it is, if we have followed, we should have been able to get like 60-70% of all of this. So I know with time, and then hopefully, if we are able to get access to the videos, it would go a long way. But regardless, I believe there are a couple of persons here that would be able to also be reached out to, with this. And I don't know if the DMs of our facilitators will be open, if we can reach out, to maybe ask some questions at a point where we are trying to replicate this training, and maybe we have one challenge or the other. That's it. Then the last thing I want to ask, I'm really curious about the aspect of the hillshade analysis. Sorry, yeah, the hillshade analysis. I don't know, Vicky, are there some standard values that you need to use, or you just like freestyle them according to what you are looking for, or how beautiful the maps look as a result of changes of some of those parameters? I don't know if my question is clear.
Yes, your question is very clear, sir. They are
Okay.
just recommended values. Normally for the brightness we use 85, but because of the hue shade of Plateau State, it's going to be too white. So I just use 50. So it depends on what you are looking for. Those are just recommended parameters that you can use.
Okay, thank you so much. So thank you, everyone.
Thank you, sir, for the comments and also the question. So please, Ayomipo, please, is there any other thing? I observed that Dr. Kamal is here with us in the meeting, so I'll give room to him to say hi. At least he's in UNIJOS, he needs to speak to us. We need to hear his voice also. So please, sir.
Good evening. He's quite busy at the moment.
Okay.
I'm representing him.
Okay. All right. Adam Yahaya is raising his hand. Please, you can speak, sir. Adam Yahaya, are you with us? I guess he's not in the meeting. Okay, Adam Yahaya, please, you can speak. Oh, okay. So Lawal Temitobe, you're presenting, right?
Yes, I am.
All right, ma'am. Over to you.
Thank you so much. All right. So, as before we wrap up, I would like to add few things. Considering the video, we'll talk to the management about it, and Mr. Monday is going to deliver to the participants. And also, we offer trainings. We just finished our data analytics course and also geospatial analysis. And the second cohort is coming very soon. So just stay tuned. All right, so let's talk about something many of you are curious about: how to get your certificate of participation. To be eligible for the certificate, here are a few simple conditions. Make sure you follow DigGeoNaija on LinkedIn if you haven't already. Then when we post about this workshop, write a positive review about it. And then you can also post on your personal page and tag DigGeoNaija in your post. So thank you so much. Thank you for being part of this first ever DUAP University session. It's been an honor to host it with with you guys, with amazing students of UNIJOS. And we hope you are leaving this session with not just new knowledge, but also a confidence to explore geospatial tools. If you would like to connect with us, you can follow us across all social media platforms: Facebook, YouTube, LinkedIn, X, Instagram. Just search for DigGeoNaija and you are going to find us there. And if you would like to join our WhatsApp community, I'll share the group link in the chat box. So thank you so much. I would like to hand over to Mr. Monday.
Thank you so much, Ma. On behalf of the University of Jos, I would like to extend my heartfelt appreciation to all who joined us for today's training. Though we we hoped for a higher turnout, but we deeply appreciate the presence of those who participated. Your commitment to learning and growing your geospatial skills speaks volume, and we are truly encouraged by your dedication. I want to appreciate Ayomipo for the constant information. He has really done a lot in making sure that this program is a success. I really want to appreciate everyone on the DigGeoNaija team, and I want to appreciate all University of the students that are present here. I also want to appreciate Mr. Bunyaminu, who has also been a strong supporter of this particular course. I want to appreciate each and every one of you guys for making out to come out and then learn from this. I'm very sure that you have learned something, and as we move forward, we begin to find its application in your career. So thank you so much, DigGeoNaija. Thank you so much, everyone. Ayomipo, please, you can speak.
Okay, thank you very much. So once again, I also like to thank everybody. Thank you for being present in this session. So as Mr. Buyamini said before, by participating in this session, you should have had about 60% knowledge of what was taught. If the recordings won't be granted, then we will release some contact details to the ambassador, which he will pass across to you all. And through that, wherever you're having some issues, you can just get through to those contacts and they provide solutions to what you are having issue with. But that is on the condition that the recordings will not be granted. But if the recordings will be made available, then that will be good. For other ways, we'll find a way such that you get to benefit well from this program. So thank you once again for having us. We really appreciate it.
All right, thank you so much, everyone, for coming, for creating time to learn. We see you another time. All right,